Hi there. Welcome to a video discussing homework number 27 and also what you'll be doing in class today on Monday, November 27th. I apologize I can't be in class today. I'm still under the weather. My whole family got sick a couple days ago right after Thanksgiving, and we're just getting over this nasty cold. So figured just one more day of rest and I should be back to top health. Should be back on campus tomorrow afternoon, but definitely will be there to teach you guys on Wednesday. Of course, if you have questions, feel free to email me. We still have our test this Friday, and we are done covering new material as I promised right before Thanksgiving break. So today's just a chance to do some review. That's what the assignment will be. We'll do homework number 28, but right now I'm looking at homework number 27, handout C and handout D. And if you go to Schoology and locate homework number 27, so just go to the main page, click on Unit 4, Chapter 9, homework assignments, homework number 27, and you will see I added two new PDFs, the handout C solutions and handout D solutions. Or if you go to the new homework, which is homework number 28, and click on that, you'll see the attachment for today as well as the solutions for handout C and D. So they're in two places. And heck, I might as well put them in a third place and put them under maybe lectures and homework files, but I'll get around to that when I get a chance. So plenty of places where you can locate the homework solutions, and I'll email it to you guys as well and put it as an update. So 5 places you'll find it, so you can't miss it. But let's talk about the solutions right now. So here for 1 through 4, you're supposed to convert each polar equation to rectangular form. So remember, r squared is x squared plus y squared, r sine theta is y, r cosine theta is x. So if you multiply both sides by r, then you can easily do the substitution and then complete the square to get the equation of the circle there. So that polar function is going to be a circle. And by the way, you can go to Desmos and verify this. If you click on the wrench, and it's not very obvious, but the grid, instead of the first one, pick the second one, then it will convert, it will allow you to do polar coordinates. And I'm going to show you how to punch in all the polar stuff when we get to handout D in just a little bit. Anyhow, number 2, you can multiply both sides by 2 minus cos theta and distribute the r. And r cos theta is x, r is root x squared plus y squared. We can also multiply both sides by r2, I believe. That should be fine if you wanted to do that. Not sure if that makes it actually more messy, so probably this way is better. Square both sides, get rid of the radical. Move all terms to one side, complete the square, you wind up getting an ellipse. So there's the answer right there. For number 3, same thing, multiply both sides by the denominator, just like we did for number 2. Convert r to root x squared plus y squared, compare r cos theta to x. Move all terms to one side, complete the square. In this case, you get a hyperbola. You have the minus in between the x squared and y squared terms. 4, same thing, multiply both sides by the denominator, convert r to root x squared plus y squared, compare r sine theta to y. In this case, you get a parabola. So it happens to be a parabola for that one. Then here we're going the other way around, going to, actually, never mind. It's still converting a polar equation to rectangular form and solving for y squared. So just kind of a funny one. It's not a conic. It's kind of a weird graph. But yeah, I trust you guys can know that tangent is y over x, squared is y squared over x squared. Secant theta is 1 over cosine theta, which is 1 over x. Sorry, 1 over sorry, r cos theta is r cos theta is x. But if we multiply top and bottom by r, which is fair treatment, then you can put x in the bottom and root x squared plus y squared, which cancels from the other side. So it requires a little bit of craftiness there. Now 6 and 7 go in the other direction. Remember, y is r sine theta, x is r cos theta. Do the substitution, factor stuff out, or collect all terms on one side, factor stuff out. And you get r equals 0, or you can get this situation as well. You can write it either way. And r equals 0, I believe, why that says included, because if you do plug in 0 for theta, you do get 0 for r. So there you go. And likewise for number 7. Again, replace x squared plus y squared with r squared, y with r sine theta, factor, and then you have your equation there. More of the same deal here. and you're squaring both x and y, so you square r cosine r sine theta, factor with r squared, isolate, and you're good there. You also get kind of crafty and convert cosine squared theta minus sine squared theta with a double angle formula, cos 2 theta. So it becomes 25 secant 2 theta if you so desire to do that. 9. Yeah, just that's a transformation. And clockwise is actually the negative direction. So you do plus 5/6. And they don't have the number 10 here. So let me go to the other handout. Oh, geez. I'll close that down. Don't need it anymore. So number 10, you're asked to consider those and analytically determine where they meet. So you set 4 equal to 3 plus 2 sine theta. And combine like terms. Sine theta is 1/2. So theta will be the inverse sine of 1/2, which should be pi over 6 or 5 pi over 6. If you plug in pi over 6 into here, you're going to have 3 plus 2 times half, which is 4. So definitely have a point at 4, kind of 5 pi over 6. Let me switch colors here so it stands out just a bit more. So let's see, 1, 2, 3, 4. Another one in the same place, 1, 2, 3, 4. And r equals 4. That's just straight up just a circle, right? Like that. And the other one, 3 plus 2 sine theta. So this is where Desmos could be our best friend. So let me show you how you actually could type this in. So remember, I went to the wrench, switch the grids there, and you can adjust x and y however you like. So if I do r, let me close that one down. R equals 2 plus 3 sine, and it's called theta. If you hit the, let me hide the keyboard. Hit the keyboard and hit ABC, and you can locate theta right there. And I actually make sure I got that equation correct. 3 plus 2 sine theta. 3, I know my short-term memory is terrible. You got that. If you want to do r equals 4, go ahead. There you go. So in this case, you have a limicon with a bit of a dimple. And so you see the intersect in those two places. So yeah, totally makes sense. And remember the dimple, that's 1. Oh, this is a 1 because you do 3 minus 2, the absolute value of that. And sine, so it's going vertical, or it's gonna be symmetrical about pi over 2 axis. So remember, if you plug in negative theta, negative r, that should indicate to us that we'll have that. Actually, sorry, let me take that back. Let me pull up the stuff on that really fast. Hold on a sec, guys. Nope. Yeah. Or replace r with pi minus theta. That could work too. And you should have that symmetry about that. Anyhow, going back again here. And we do that graph. Switch colors to green. So again, you have that dimple here, and it also goes up to 5 on the other direction. 1, because when you plug in pi over 2, you're gonna have 5. When you plug in 3 pi over 2, you have 1. 1, 2, 3, 4, 5. Yeah, it's kind of a crappy graph, but there you go. And those are the actual intersection points. So 4 comma pi over 6 and 4 comma 5 pi over 6. Okay, so it's kind of a nice lead to the next handout. I just made this answer key this morning. So if we can read it well. So for number 1, you just want to move all the terms to one side, or actually substitution, right? And move all terms to one side, and just factoring. Now, sine theta plus 5 is impossible because sine can't be negative 5, so you don't worry about it. Sine theta, 2 sine theta minus 1 equals, you get that, equals 0. Sine theta equals half. You get pi over 6 and 5 pi over 6. If you go to Desmos, so let me close these down. Don't need that. Don't need that. And I typed stuff in advance just to save time. So, that's a weird one. The first graph, the other one, just a circle. And now it looks like it intersects at 7 pi over 6, 11 pi over 6. But if you go back, if you plug in 7 pi over 6, 7 pi, sine 7 pi over 6 is negative half. Negative 9 times negative half is actually going to be 4.5. But actually, let me take it back. If you plug in pi over 6, if you plug in pi over 6, because that's what we got algebraically, you have negative 9 times sine pi over 6, negative 9 times half is negative 4.5. Because the negative r value, it jumps 180 degrees, and that's why it's at 7 pi over 6. So that's why you actually see a point at negative 4.5, sorry, 4.5 comma 7 pi over 6, because the same thing as negative 4.5 comma pi over 6. Because if you're over here at pi over 6 and negative 4.5 r, you have to do that 180 degree rotation, which shows it over there. And likewise, for 5 pi over 6, you also have negative 4.5 as r. You have to do 180 degree rotation, which gets you 11 pi over 6. So don't be alarmed that you don't see pi over 6 or 5 pi over 6. It's because you had a negative r value when you plug back into the original equations. So that's what's going on with that one. And if you plug in the first one, same thing. Sine pi over 6 is 1/2. A square is 1/4. 2 times 1/4 is 1/2. Half minus 5 is negative 4.5 again for r. Now let's go back to here. Now, interestingly, these don't touch. If you were to, well, first, if you solve it, the 2 cosines cancel. Negative 2 is not equal to negative 4, so there's no solution. And these don't touch. If you see for yourself, these are not touching. So yeah, that's what we get for that one. You have a cardioid with kind of a what they call a damped limicon. For number 3, you could divide both sides by cos theta. Cos, then it would be tan theta equals 1/√3. That's at pi over 6 to 7 pi over 6. So that's what we see here, which is going to be definitely at pi over 6. 7 pi over 6 apparently is extraneous. Not 100% sure why, but it doesn't show up. So that's what we're saying is that you have to look at the graph and where are the actual intersection points. So that's not an actual intersection point when you graph that. They do intersect the pole though. And that's because, yeah, totally, if you plug in 0 for sine, you get, point at the pole. If you plug in pi over 2 for cosine, you get a point at the pole because r is going to be 0 in both those cases. So eventually they are going to meet at the pole, which doesn't show up as an actual intersection point when you do it analytically, but graphically it does show up. And of course, 7 pi over 6, it's just not showing up at all. I mean, they're both negative there. Oh, I know why. Okay, sorry, just hit me. If you do cosine 7 pi over 6, that's negative √3/2, but the r's got to flip over 180 degrees to get to the pi over 6. And likewise for 3. So that's why when we do that 180 degree rotation, it doesn't show up as an actual intersection point because of the negative r value in the rotation. Okay, just hit me. The light bulb turned on. My apologies, I didn't see that earlier. So sometimes I feel like I'm a student here too, this stuff. Okay, for number 4, again, semi equal to each other. Tan 3 theta equals 1. 3 theta equals inverse tan of 1. So inverse tan of 1 is pi over 4 and 5 pi over 4, but because of 3 theta, we're doing 3 revolutions. So you're going to have to consider 4 more cases. Second revolution and third revolution, there's 2 more values for each of those revolutions because you want the answers between 0 and 2 pi. 2 pi not being inclusive, 0 is inclusive. So you want to gain these 6 values. So now if I graph those for number 4, you get that. So we see here there's actually going to be just 4 intersection points. Definitely the pole, which doesn't show up in the algebra, and just 3 other points. And it looks like that's happening at pi over 12, and then 120 degree rotation. So it looks like that will be 9 pi over 12, 3 pi over 4, and then 17 pi over 12 after that. So the second, fourth, and sixth solutions are discarded. And I'm guessing that's probably because you get negative r values and they flip over and you just get the 180 degree counterparts on the other side. So I'm guessing that's probably like why you don't see a point right here or right here or right here because they jump over. So that's why those are not actual intersection points because of negative r values. Okay, the light bulb just turned on for me. Here we got a rose curve, it looks like, with a circle. Remember when the coefficient is even, the number of petals will double and sign, so it's a little bit off-centered. But you solve it, use double angle identity for sine 2 theta, factor out cos theta. So you get 4 answers here. Clearly they intersect at pi over 6 and 11 pi over 6. But remember, when you do 5 pi over 6, things will flip with given the negative r value. Pi over 2 and 3 pi over 2 are actually going to be the poles. And so that's what's happening there, because r is 0 in each case. So in this case, the pole does show up algebraically and does show up in the actual graph. So when I asked for actual points of intersection, we want to make sure that the actual points actually mean, sorry, that's a little play on words, what you see graphically, that's physically what's happening. So analytically, it may not confirm it. So not all the analytical solutions will be used. And the buck stops with the graphical solution, just so you know. So if the analytical solution doesn't show the pole intersecting, but you do see it graphically, I do want you porting the pole as an actual. So actual, let's just say, is the graphical solution, because that's actually what's happening, right? They're actually touching. Even though the analytical may not support it necessarily. For 5, actually, sorry, we just did 5. We got one more, number 6. These are some weird ones. Zoom out. And we see 6 points of intersection, but here, yeah, actually, it looks like that's all covered. Okay. Yeah, it looks like it's all covered. And it's going to be kind of funny the way some of these look. Like 2 pi over 9 is a little bit past pi over 6, but that's probably because it doesn't have any degree of rotation. So there's a lot of rotations here, depending on what the r values that go with them, because some of the r values might be negative. Like, for example, if I plug in 2 pi over 9 to 7 cos 3 theta, I get cos of 2 pi over 3. Cos of 2 pi over 3, I know, is negative half, so it's negative 3.5. So it's got to jump. So 2 pi over 9 is over here roughly, but it's got to jump, so it's down over here. And it's a negative 3.5 because you see raised to 2, raised to 4, and that's 3 right there. So 3.5 is right there. And it's supposed to be on the other side at 2 pi over 9, but it's not happening. 2 pi over 9 is a little less than pi over a little less than pi over 3, because pi over 3 is 3 pi over 9. So it's supposed to be somewhere over there. So we see it does line up if you were to actually plug in all those values. So it seems like all 6 are valid, but you have some negative r values that are happening. So you do see these 180-degree rotations. And that's it. Okay, so that covers all the solutions. The classwork for today is right here. It's going to be some stuff of parametric equations. We did cover parametric equations after, or maybe right before the conics test. I still need to assess that. So there's some problems here on that. Hopefully your sub can make a photocopy. The photocopy machine is down on the 2nd floor. If you can't, then you'll have to just work from the screen and just do it on a piece of paper. Full equations and graphs. That's obviously this right here. Feel free to do this in your table groups and use your calculator and Desmos to help you out. So here I'm just kind of asking to analyze this equation, doing all these different things about it. Find the zeros, find the symmetry, blah, 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 all this stuff here. Then here I give 2 portions of a graph, determining what intervals give each portion. So feel free to use your graphing calculator, and then and labeling the points here for A through E. So just getting a little more exploration with polar graphs, just more practice. I'll have more review stuff ready for you guys on Wednesday. As for the test itself, going to Schoology, I did put a little more, I made an update actually. If you go here and click on that, so it's gonna be 5 questions to get 45 minutes. There'll be 1 question about a parametric equation. I won't say exactly what it'll be like, but maybe eliminating the parameter, graphing something that's parametric. Analyzing the graph of a polar equation, which is basically what you're doing today, which is right here. So doing all that stuff. Converting. So you have handout C, the 3rd and 4th items, and then solving system, we just talked about handout D. So yeah, so that's what the test will be. No surprises. Should be very, very straightforward. It'll be designed to last 45 minutes, but you can use 6 minutes if you need it. Um, and then when we're the next week, I do have to squeeze in a small topic on vectors. There won't be a test on it, but there's still some material to cover for that. And then by Friday of next week, which will be December 8th, I'll have the final exams review guide ready. I'll try to get ready before earlier if I can, but I'll need 2 full days to cover vectors because that's important that we do need to talk about that. And then yeah, then we'll have 3 full days for review, December 8th, and then the 12th and the 14th, I think we meet, if I'm not mistaken. Look at the schedule here. It's kind of a wonky schedule a couple weeks from now. Yeah, 12th and the 14th. The final will be on the 15th. So yeah, it's coming up fast, guys. 2 weeks from this Friday, we got the final exam. So less than 3 weeks from now. All right, done with the video. Why don't you guys work on the handouts? Again, the handout is right here, 5 pages. Whatever you don't finish is homework, and make sure you submit it to Schoology. And that's that. Okay. I'll see you guys later and stay healthy. Goodbye.